Remember when you were a kid, you had those building toys like Connects? You could snap those little pieces together and build just about anything you could imagine? Well, what if I told you the entire universe is built using a set of rules that's, well, surprisingly, just as simple?
I mean, that's a massive question, right? How do you build everything? From the water you drank to, the chip inside the device you're watching this on right now? It all seems so incredibly complex. But what if the secret sauce isn't really all that complicated?
The secret is that nature basically has this simple, elegant instruction manual, kind of like a good toy set. And once you get the hang of how the basic pieces connect, you can start to see how literally everything is put together.
All right, so let's dive in. To build anything, we've got to learn these rules of connection. And it all kicks off with something called electron shells. This is basically the atomic social club, where atoms figure out who they're going to team up with and how.
Okay, here's the way to think about it. Picture an atom as a giant concert venue, right? And the electrons, they're the fans. So the first fans, the super eager ones, they rush right down to the pit, right in front of the stage. Once that's totally packed, the next wave of people starts filling up the main floor, and then the balcony. Electrons do the exact same thing. They fill up these energy zones, we call them shells, starting as close to the center of the nucleus as they can get, and then they work their way outwards.
And this brings us to our very first magic number. And it's a simple one, 2. That first shell, that mosh pit right by the stage, it's pretty small. It can only hold a maximum of 2 electrons. That's it. It's like a little 2-seater sports car. Once you've got 2 people in, it's full. No more room.
Okay, so once that sports car is full, then the electrons start piling into the second shell. And this one is way bigger. Think of it like an 8-passenger minivan. It can hold a grand total of 8 electrons. So remember these 2 numbers, because they're the key to pretty much everything we're going to talk about. 2 and 8.
So this takes us right back to our KNX set. That first shell, the one that holds 2 electrons, it's just like this orange connector piece. See, it's got exactly 2 spots for a connection. And the second shell, that's our white 8-way connector. It's got, you guessed it, 8 connection points. And the electrons themselves, well, they're the little green rods that you snap in to actually make the connection.
Okay, now that we have our pieces, let's meet the first 2 elements you'll find on the periodic table, and you'll see they have totally different personalities. And it all comes down to how many of those green rods, those electrons they've got. So it really just boils down to this. Over here we have hydrogen, it's got 1 electron, so its first shell, our little orange KNX piece, has 1 connection made and 1 empty slot. This makes it super reactive. It's always looking for a buddy to fill that empty spot. Then you have helium. It's got 2 electrons, its first shell is completely full. It's stable. It's a total loner, perfectly happy all by itself, doesn't need to connect with anyone.
So the big question is, how do atoms like our needy friend hydrogen find a partner and get stable? Well, they've got 2 main moves they can pull. They can either share their electrons with another atom, or they can just straight up trade them.
All right, let's tackle sharing first. So when 2 of those hydrogen atoms bump into each other, each with its 1 lonely electron, they basically make a deal. They decide to share their electrons so they can both use them at the same time. Think of it like 2 friends with only 1 pair of headphones. Each one takes an earbud, and now they can both listen to the music. By doing this, both of those hydrogen atoms get to feel like their first shell is full and stable. The other option is trading. And this is where it gets interesting. So let's meet lithium. It's got this 1 lonely electron way out in its outer shell that it is desperate to get rid of. It's just extra baggage. Then over here you've got fluorine, and its outer shell has just 1 empty slot that it desperately wants to fill. I mean, talk about a perfect match, right?
And boom, it is the perfect trade. Lithium just gives its extra electron over to fluorine. And in that instant, they both become stable and happy. Lithium's new outer shell is now its first shell, which is perfectly full with 2 electrons. And fluorine, its outer shell is now perfectly full with 8. And because of this little trade, they become oppositely charged. And they just snap together, sticking to each other like tiny little magnets. And just like that, they formed a brand new, super stable molecule.
And this new molecule they form, lithium fluoride, it's not just some textbook chemistry example. No way. As you can see from this quote, that simple little trade between 2 atoms creates a material that is, and this is not an exaggeration, absolutely essential for some of the world's most advanced technologies.
So let's really dig into that. Let's see how these little atomic KNX pieces just snapping together build something so incredibly important. We're going from toy blocks to high tech.
So because that bond is so strong and so stable,
Lithium fluoride has these just unbelievable properties. It can take insane amounts of heat. It's super resistant to radiation damage. You can hit it with a sudden temperature change, what we call thermal shock, and it won't crack. On top of all that, it's amazingly transparent to specific kinds of light. I mean, it's basically a superhero material.
And this is where you really see why it matters. We're talking about next-generation nuclear energy, where it's used as a coolant in molten salt reactors, something that can handle crazy temperatures and radiation. And, in the world of semiconductors, it's used to make the super high-purity lenses that etch the tiny, microscopic circuits onto our computer chips. And all of that power, it all comes from one simple little trade of a single electron.
Okay, we have covered a ton of ground here, right? We've gone from simple toy parts all the way to nuclear reactors. So let's just do a quick recap of the fundamental rules, our atomic building guide. So here's your atomic toolkit. It really just boils down to 4 simple ideas. Number 1, electrons live in shells, and those magic numbers are 2 for the first one, 8 for the second. 2, the ultimate goal for pretty much every atom is to get a full outer shell so it can be stable. 3, they get there by either sharing or trading electrons. And 4, the result is a happy, stable atom. That's it. That's the entire instruction manual for building the universe.
And these simple rules, they're not just for a few molecules. They govern how everything is built. We're talking water, DNA, even the stars in the sky. It's the foundation for all of chemistry, all of biology, all of material science. So now that you have the toolkit, now that you know the rules, the real question is, what are we going to build next?